the last test we're going to talk about is called the root test. This is another test that is not used too terribly often, but once I reviewed it, I really liked it. It is really, really easy, and it is good for when the whole fraction is under a single exponent. So, whole fraction is a single exponential. Unlike the ratio test where we had different exponentials going on the two different pieces of the fraction, in this one we're looking at, this is good for ones and it's super, super simple. And it's really good for ones where the whole thing can be written as one exponential. So like in A, I can write this as e squared, which is a number by the way, over n, all to the nth power, because both of those have that n in the exponent. So what that means is I can take the limit as n goes to infinity, and I can just do the nth root. So basically I'm saying I don't care what that power is there. E squared over n, the nth root. And then to the n power right there. Because what that's going to do is it's really just canceling that exponent. And we're just saying, well, what's going on with that fraction? What is that fraction doing? That's the piece that's going to matter. So we're really just identifying what's going on with e squared over n, that limit as n goes to infinity. So as n goes to infinity, the denominator is going to get super, super huge. That limit is 0. And so 0 is less than 1. This thing is not growing. This series is not going to get bigger. It's getting smaller as it goes. So it's going to converge. Again, this is just letting us ignore that exponent so that we can just focus in on what's going on the inside of that fraction. What is that limit doing? It's called the root test, but it's something that you've really been using all the way since AB calculus. The very first unit we did was limits, and you actually used this reasoning. So that's why I just forgot that it was an actual test, because it's just kind of like what we do. So when we do B, the actual formal work for that is the limit as n goes to infinity, and we're going to take the nth root. And we're going to say 3n plus 4 over 2n, and all that to the n. But really all that's doing is it's just canceling that so that we can identify what's going on inside. So we're going to really think about that limit. 3 to the n plus 4 over 2n. And we're going to say, well, that limit as n goes to infinity is 3 halves. So 3 halves is greater than 1, which means this is going to diverge because it's getting bigger. The value of that fraction is getting bigger with every iteration, so it's going to diverge. Next in class, we're going to do some practice problems of just all of these different tests. Keep in mind, you might use one test, the answer key might have another, but as long as you get the same answer, there's more than one test you can run on any given problem.